Welcome. Today we're going to talk about indirect proof and triangle inequality. So indirect proof can also be called proof by contradiction, which is probably a more appropriate name for it, I think. So when you're writing an indirect proof, the first thing you have to do is to identify what exactly it is that you're trying to prove, of course, and then you assume the opposite temporarily, and then you use direct reasoning to show that it'll lead to a contradiction. And if it leads to a contradiction, then you can say that since the assumption is false, the original conjecture must be true, because you can't have a false premise with a true conclusion. So that's the idea. You assume the opposite and then show that that can't happen, and since that can't happen, the original conjecture must be true. So if you were to write an indirect proof that a triangle cannot have two right angles, let's suppose we take triangle WHY, so that's what we're given. And we want to try to come up with something that says that it can't have two right angles. So what we do is we say we're going to assume that angle W and angle H are right angles. So that's sort of the first step. You need to assume the opposite of what you're trying to prove. We're trying to prove that it cannot have two right angles, so we assume that we have two right angles. So if that's the case, then by the definition of right angles, that means that the measure of angle W equals 90, and the measure of angle H equals 90. And we also know that the sum of the angles of a triangle is equal to 180 degrees. Therefore, we have the measure of angle W plus the measure of angle H plus the measure of angle Y equals 180. And if we have those three angles together adding up to 80 and then we substitute in, we get 90 plus 90 plus the measure of angle Y equals 180, a little bit of subtraction, and we end up with the measure of angle Y equals 0. If the measure of angle Y equals 0, then we don't have a triangle because we don't have that third angle. Therefore, it must be true that a triangle cannot have two right angles. And there's a number of different ways to go about that, but that's the main idea. And of course, I didn't put all the reasons in, but I just wanted to give you a feel for how that might all work. And one thing that will also work for us is some of the angle-side relationships in triangles. So this has to do with the triangle inequality stuff. If two sides are not congruent, then the larger angle is opposite the longer side. If you think about a door opening, and you have, because basically the door and the opening to the door have the same length, and you open up the door wider, that third side that would be connecting the open part of the door with where the door would close keeps getting larger. The angle across from that gets larger. So, that sort of, I think, puts it in a little bit of perspective. So if you have the larger the angle, the longer the side. That's basically what these two theorems state. So if you look at it, one of them says if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. Larger angle, longer side. It should make sense, even if you've never thought of it before, as you look at some triangles. So if we have these two problems, we have to write the angles in order from smallest to largest. And there'll be times, and these look fairly obvious just from the diagram, but you can't go by that. But we can order it. We have enough information here. We have 9, 15, and 19.5. So the smallest angle in this case is going to be angle B. And then the next smallest is going to be angle A. And the largest angle is angle C. So it goes angle B, angle A, angle C, smallest, and then the second smallest, and then the largest angle. Should make sense. And then for 2B, we have write the sides in order from shortest to longest. If this is 22 and this is a right angle, then we should be able to figure out what angle E is. F is obviously the largest angle, so that's going to give you the longest side. Write the sides in order from shortest to longest. So EF is going to be the shortest side. And then we have DF as our second shortest. And then our longest side is going to be side ED. So we have EF is the shortest, then DF, then ED. From shortest to longest. Next triangle theorem has to do with whether you can make a triangle given three sides and what relationship the sides have. So the sum of any two sides of the lengths of a triangle is greater than the third side. So you can't make a triangle out of sticks that have lengths 1, 1, and 7, because that 1 and the 1 aren't going to be able to put together to give you that third, to connect at that vertex and give you a third side. So really, the way to think of it is any two sides of a triangle have to add up to be more than the third side. So no matter how you pair them. So if you take the two smallest, they better be able to add up to more than the length of the third side. So for 3A, 8, 13, and 21, 8 and 13 is 21. That'd be 21 exactly. So if this is 8 and this is 13 and this is 21, you put those together, it's not going to give you that third side, because you have no angles. So that's not going to work for us. So that's a no. 6.2, 7, and 9. The two smallest sides are 6.2 and 7. They add up to more than 9. 7 and 9 add up to more than 6.2. So yeah, that seems to work out all right. And then for the third one, we have t minus 2, 4t, and t squared plus 1 is when t is 4. So 4 minus 2 is 2. 4t, 4 times 4 is 16. And then we have 4 squared plus 1 gives us 17 for our three sides. Can any two of them add up to be more than the third? 2 plus 16 is 18, so that seems to work. 16 and 17, obviously, and 2 and 17, so that works as well. So the first one, that's 8, 13, and 21. It wasn't more than 21, so it doesn't work. The other two seem to. I think this one's very straightforward as well. Hopefully that worked out for you, and we'll see you next time.